All right, welcome to your notes for chapter 5.6, inverse trigonometric functions. In 5.6, we're going to cover inverse trigonometric functions for derivatives. They start in this section by sort of reviewing overall why chapter 5 is separated out. So chapter 5 is actually titled something about transcendental functions. And transcendental functions are functions that are not considered algebraic. These functions are basically the ones that we've been focusing on. So you've got your logs, you've got your exponentials. They actually include our trigonometric functions. So in a sense, we've been working on some transcendental functions this entire time with sine and cosine and tangent and so on. If you notice, though, for most of the ones that we've been working on, the derivative of your transcendental function can be pulled back into an algebraic function. So for example, the derivative of log x was 1 over x. So in this case, we have a truly transcendental function with an overall algebraic function. And the derivatives of inverse trig functions work the same way. So just as a quick reminder, we have our algebraic functions. If you wanted to categorize things, this includes things like our polynomials or our rational functions. And we can contrast that with transcendental functions. Transcendental. And that includes trig functions, log functions, natural log functions, exponential functions, base A or base E. And now the last one that we're adding in are inverse trig functions. And like natural logs, we are going to take these inverse trig functions and we're going to write their derivatives algebraically. So that's what we have in the box here. You want to memorize these ones. So the derivative of arcsine, or sine inverse, is u prime over square root 1 minus u squared. You could probably pause here and then maybe pick back up again in a second. I'll write them all out really quickly. And then I will point out to you some commonalities that might help you to memorize these. I also want to point out all of these are written with u's rather than x's. So if you wanted to make a little note to yourself here, u is a differentiable function of x. So we're sort of implying the chain rule on each and every one of these. Last one, we've got our secant and our cosecant, u prime over absolute value of u, square root u squared minus 1, and negative. Make sure you've gone ahead and copied them carefully. You can double check them in the textbook if you need to. If you notice, right, they come in pairs. So sine and cosine are just opposites of one another. There's the negative sign, but they both involve that square root 1 minus u squared. The order matters, be careful. Okay, it can't be u squared minus 1. That would lead you into a different space. Tangent and cotangent, no square roots on the bottom, addition. And secant and cosecant have the most complicated ones. The 6 of these are just something you have to memorize. To be perfectly honest, if you're looking at the AP test of past, there's probably not a ton of questions on inverse trig. That's why we're covering it very quickly. You would probably see arcsine or arctan, maybe arccosine or arccotan, since they're so closely related. And they would probably have maybe one question. So you want to memorize these, but overall, don't spend all your energy reviewing for the AP exam on this particular section. It's not a lot of bang for your buck. But we do want to go over it so that you are prepared, and it gets used a lot. Inverse trig gets used a lot in BC. So if you're moving on, this section is more important than just that one question on the test. Here we have a nice basic example, a really easy u value, right? The part that's inside of our arcsine is the 2x. So that would be my u value. And I could simply write, focusing on that first formula up here, the derivative of 2x being 2, and then I would have the square root of 1 minus, and when I square it, don't forget product to a power. You've got to square both pieces. So once they're memorized, they're pretty easy to work with. Here, I probably could have benefited from some parentheses, but arctan of negative 3x squared. We're going to focus our attention on this formula right here, right? U prime would be negative 6x, and then underneath I would have 1 plus. When you are squaring that negative 3, you're going to get a positive 9, and x squared squared, x to the 4th. Pretty simple. The hardest part is memorizing the formulas. Let's see. I think the bottom one's more of the same, right? A little bit more simplification on number 3 here, right? So much like the one right above it, the formula is to take the derivative of the inside. So here that would be 1/2 x to the minus 1/2. And then underneath, I would have the square root of 1 minus, and then I would have the square root squared. Okay. It might be easier to think of this as a product. This numerator would be 1 over 2 roots of x, and then that denominator would be 1 over, and then I would have 1 minus just simply x, right? The square root squared. You could write this different ways. You could write it just like this and finish right here. I think if I peek at the textbook where I pulled this from, they sort of combined a little bit more. Not 100% necessary, but since they're both underneath, you could multiply them together, and it would look something like that. Here's one with arcsecants, right? We can go back to that formula just a little ways above. We're going to put our derivative on top so we can practice our e to the 2x. That would give us 2e to the 2x. And then underneath, I would have the absolute value of e to the 2x, just plugging my u in. And a square root, if you square, right, power to a power, you multiply. So e to the 2x squared is going to give me e to the 4x, and then minus 1. Absolute value, remember your exponential function is always positive, right? So I could actually drop those absolute values and it wouldn't change the sign whatsoever. And then if you notice, right, this one would actually disappear here. And my overall best answer would be just 2 over the square root of e to the 4x minus 1. That one's a pretty basic simplification. Nothing too tricky there. So there you go. That's sort of the basics. Let's flip it over and we'll do one that's a little bit harder. I'm going to move on to video 2 just so we don't get cut off.